welcome back to Mrs. Thompson's classroom. Today we're going to be looking at the law of sines again. And in particular, we're going to be looking at what is called the ambiguous case. In this case, we're given side-side angle. So let's take a look at what that means. So it means that we're going to be given two sides and then an angle that is opposite one of those sides. Now, in geometry class, when we had our postulates for proving congruent triangles, we never used this one. And that's because this does not necessarily guarantee a congruent triangle, because we may have no triangle at all, or we may have a triangle, or we may have two. So that's why it's called the ambiguous case. So let's see why. So the first thing we're going to do is we're going to drop an altitude here, and this is the height. So we know that sine of A is equal to H over B. Okay, so that means that H is equal to B times the sine of A. Now, occasionally in this scenario, this height will end up greater than A. So if H is greater than A, then what we get is this triangle, and here's our height, but A is too short. So if A, okay, A is our opposite, is less than the height, we actually have no solution. Okay? Now, if H happens to equal A, then what we end up with is one right triangle. Okay? Now, these other two scenarios end up giving us either one triangle or two. So let's walk through one of these problems and figure out why. So here is a scenario. We have A being 5, the opposite side 10, and angle B is 52. So let's start by setting up our law of sines. I know that 10 over the sine of 52 is going to equal 5 over the sine of A. So if I cross multiply, and then I divide, I know that sine of A is going to equal this quotient. Now, in order to find A, what we're going to have to do is undo sine. And the way we do that is we take the inverse sine. Inverse operations undo one another. And so when I plug this in the calculator, it will give me that angle A is 23.20 degrees. Okay, now knowing that will allow me to find my third angle. So angle, we'll call it angle C. So the measure of angle C is going to equal 180 minus 23.20 minus the 52 we were given. And that will give me 104.8 degrees. Now, once I know angle C, I can now go back to my law of sines. And find little c. So little c is going to be 10 times the sine of 104.8 divided by the sine of 52. And the calculator will give me that value as 12.26. Or actually 27 when I round it off properly. So by law of sines, I found a solution. So if I had gone back and found that height, okay, the height is going to be 5 times the sine of 52. I get 3.94, which is less than 10, so I know I have a solution. It's also not equal to 10, so I know it's not a right triangle. Okay, and so in this case, we have our height is less than the opposite, and we have the adjacent is also less than the opposite. Okay, but the adjacent is bigger than the height as well. So they're both bigger than the height. So if we look back up here, we have opposite bigger than adjacent, but the height is not less than those things. So this is the one triangle. So it's in this last scenario that we get 2. Okay. All right, now how would I know if I have 2? Let's keep doing some examples. So let's take example 2. So I'll have 10 over the sine of A equals 5 over the sine of 52. Now notice these are the same numbers as in the previous example, but I flip-flopped my opposite and adjacent. So this means the sine of A is going to be 10 times the sine of 52. I'll cross multiply, okay? And then we divide. This is how we solve proportions, right? So when I plug that into the calculator, I get sine of A equals 1.576. So if I try to take the inverse sine of that, this is going to give an error in your calculator. And the reason being is because sine is always less than 1 and greater than -1. We learned that from our unit circle. The unit circle has a radius of 1, so sine and cosine can never get bigger than 1. So this is larger than 1, so it can't happen. There is no such sine value. And so this scenario tells me there is no triangle. There is no solution. So if I had gone back and found my height, it would have been too big. Okay? All right, another one. So let's say we take, in this case, we'll have 10 over the sine of x equals 9 over the sine of 52. So the sine of x is equal to 10 times the sine of 52, cross multiply, divided by 9. So now angle x is going to be the inverse sine of that quantity. And we'll plug this into our calculator. And it gives us angle x is equal to 61.11 degrees. Now that will allow me to find angle z. We'll call the third angle angle z. So our triangle is y, x, and z. Okay? All right, so this would be 180 minus 61.11 minus the 52 they gave me to begin with. And that gives me 66.89. So I now know all 3 angles. So now I'm left to find my third side. So little z over the sine of 66.89 is going to equal 9 over the sine of 52. That same ratio that we started with up here. So this will allow little z to be 9 times the sine of 66.89 divided by the sine of 52. So when I calculate that out, we end up with z equaling 10.50. So I have found all 3 sides. So we have a triangle, and it's not a right triangle, but do I get a second solution? If I were to find my height, I could compare it to my opposite and adjacent, and I would know. But that would require me to memorize that little chart at the beginning. But let's say I forget. So here's how this is going to be related. I'm going to take this first angle that I found, okay? And my second possibility for angle X is going to equal 180 minus the 61.11, which gives me 118.89. Okay? Now, I can then use that angle to find angle Z, second possibility. So the three angles have to add up to 180 degrees. Now the 52-degree angle that they gave me to begin with doesn't change, so I still have to use it. But I'll do 180 minus 118.89 minus 52, and I get 9.11 degrees. So it's a pretty small angle. And this is not unusual that in one of the cases when we have two, that we get an obtuse angle. Okay, so one of the scenarios is looking like this with an obtuse. The other option is going to cut across here with an acute. Okay, so I get the two different X values there. Okay, so now that I know that, I can find my second little Z. Still using the 9 and the sine of 52 because that was given. It doesn't change. So little z, option 2, is 9 times the sine of 9.11 divided by the sine of 52. Plugging that in my calculator, I get little z is 1.81. And so now we have found all three missing parts for our second solution. Okay, so we don't have to memorize that chart. All we have to do is work the problem and we'll figure it out. But you always should do this right here and check for that second solution. So let's go back to the first example and see why it doesn't have a second solution. Okay, so let's say we tried this and we're going to see if it has a second solution. What would happen? Well, let's take angle. The first angle we found was angle A. So angle A, option 2, is going to be 180 minus 23.2. And that gives me 156.8. Now that's a pretty big obtuse angle. So when I go to find angle C, it has to equal 180 minus 156.8 minus the 52 they gave us to begin with, and that's going to end up being a negative number. In fact, it's negative 28.8 degrees. Now we know how to deal with negative angle measure, but inside a triangle, this cannot happen. Inside a triangle, we will be describing all three of our angles as in positive measures. So therefore, this can't happen. So there is no second triangle. Okay. So if you work through the problem and you always just check for that second solution, you'll know whether it exists or not. So hopefully that helps you kind of finalize law of sines in our minds. We can use it in all these different scenarios. And so we'll talk next time about those couple of times, like side, 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 when we couldn't use it. And we'll discover a law based on cosines that we can solve those problems with. So join me next time. See you then.